Hi, this is Mr. Manley. In this video, we are going to look at some basic graphing review. Graph of a line and the graph of a parabola. This line here we see is given in the form y equals mx plus b. So we've got a slope of 2/5 and a y-intercept of -5. First thing we want to do is graph the y-intercept at -5 and then take into account the slope. The slope here of 2/5. Remember, slope is rise over run. So rise is in the y direction, run is in the x direction, or vertical and horizontal, if you will. So I'll do a rise of 2, and then a run of 5. And that'll find my second point, and that's all we need for a line, 2 points. We just want to connect those points, and that is the graph of the line. Y equals 2/5x minus 5. Now let's take a look at if that slope were negative. So we still have a y-intercept at -5. But now we've got a negative slope. And I'm going to rewrite that and attach the negative to the numerator. And that is what I will always do with slope. I will always attach a negative to a numerator. And I'm allowed to do that, right? If we write, say, just -1/2, just for instance, well, that's equal to -1/2, which is equal to 1/2. Those are all equivalent. It doesn't matter where I write the negative. And when I'm graphing an equation in the form y equals mx plus b, if I have a negative, I am going to attach it to the numerator. And in that case, since the numerator is the rise, the negative tells me go down 2 units. And then the 5, as it did before, sends us 5 units to the right. And we've got our second point. Draw a line through those 2 points. And that's the graph of the line. So that's the graph of a linear function in the form y equals mx plus b. Simple enough. Now let's look at the graph of a parabola that is in the form y equals ax squared plus b. So this is just one form of a parabola. It would be quite a different story if I had y equals ax squared plus bx plus c. And the middle term here is going to complicate things. But we don't have that in this case. We just got ax squared plus b. And I'm going to begin as I would begin with most graphing. Now, I did not begin this way with the slope-intercept form of the line. But in this case, and most cases, I will begin with the table of values. For a parabola of this form, now in other forms, I would not begin like this, but for a parabola of this form, I will say that I'm going to look for 0, x is 0, x is 1, and x is 2. And what are the outputs? So I'm going to plug in here. This notation, that means I'm plugging in a 0 for x. I could read that as y of 0. It's not exactly function notation, but I'm going to talk about it as if it were. So what do I have? Negative 4 times 0 squared plus 7. All right, well, this is all 0, right? 0 times anything is 0, and then plus 7. So I got my y output there. Then I'm going to do y of 1. That would be negative 4 times 1 squared plus 7. All right, now be careful here. This square does not apply to this negative. If I wanted it to apply to that negative, I would have had to put parentheses. So the function would have had to have been written like this, y equals, and then I would have to put parentheses around this squared. Now, in that case, the square would apply to the negative with parentheses. But there's no parentheses here, so it doesn't apply. So in that case, we've got negative 4 plus 7 is 3. Okay? And finally, y of 2, that'll be negative 4 times 2 squared plus 7, negative 16 plus 7, negative 9. All right, let's plot these 3 points. Got a point at 0, 7, 1, 3, and 2, negative 9. There. And you should recall, I would think, that a parabola, when you learned a parabola, if you look over here to the right, you learn that parabolas have symmetry. So we have these mirror points, right? If I have a point over here, I have a point over here. A mirror image through this axis of symmetry. This being the axis of symmetry. So let's use that with these points here. I've got this point to the right, so that means I'm going to have this point 1 unit to the left. I've got this point 2 units to the right, so we're going to have this point 2 units to the left. And there's our points. I didn't emphasize this to begin with, but we were instructed to plot 5 points, including the vertex, 2 points to the left, and 2 points to the right. And that's what we have here. When the parabola is of this form there, y equals ax squared plus b, the vertex will always be on the y-axis. So we can connect the dots here and make a parabola shape. And we're done. That is the graph of a parabola in the form y equals ax squared plus b. And you will see more complex ones in the future. And we'll have to have a different approach for that.